Welcome to GATE class. In this class, we are going to study the Fourier analysis of continuous time signal and system. So, in this class, we will do the Fourier analysis of continuous time signals and systems. So in this class, first we are going to do the Fourier series representation of periodic signals. So Fourier series representation of periodic signals. We are going to do the Fourier series analysis of periodic signals. So let us discuss the periodic signals. So a continuous time signal xt is said to be periodic. A continuous time signal xt is said to be periodic if there is a positive value of t. If there is a positive value of t, there is a positive value of t for which this condition satisfies. That is xt plus t is equals to xt for all values of t. So if this condition will satisfy for that positive value of t, then this is called a periodic signal. So the fundamental period capital T naught. So the fundamental period capital T naught of xt is the smallest positive unit, positive value of t for which equation 1 will satisfy, and f naught is equals to 1 divided by t naught, and f naught is equals to 1 divided by t naught, where f naught is referred to as fundamental frequency. So what is f naught? So f naught is referred to as fundamental frequency, and t naught is equals to 1 divided by f naught. It is called a fundamental time period. So t naught is called the fundamental time period. Now two basic examples of periodic signals. Two basic examples of periodic signals. Are real sinusoidal signal, So and exponential signal, so complex exponential signal. So let us first write that xt, that is equals to cos omega naught t plus phi. So this is an example of periodic signal. This is an example of periodic signal, and there is another example, that is complex exponential signal. Complex exponential signal. So this is also an example of periodic signal, that is xt is equals to e raised to the power j omega naught t plus phi multiplied by some amplitude. Here we can multiply with some amplitude. So a is basically the amplitude, and this phi is phase angle, and omega naught is angular frequency, and omega naught is equals to 2 pi f naught, and f naught is that frequency in hertz, So let us discuss the complex exponential Fourier series representation. Let us discuss the complex exponential Fourier series representation. So let us discuss this complex exponential Fourier series representation. So the complex exponential Fourier series, representation of a periodic signal, Fourier series representation of a periodic signal xt with fundamental period t naught, is given by xt is equals to summation k is equals to minus infinity to k is equals to plus infinity ck e raised to the power jk omega naught t, where omega naught is equals to 2 pi divided by p naughts. So what is ck? So ck is known as the complex Fourier coefficient. Ck is known as the complex Fourier coefficients, and is given by ck is equals to 1 divided by t naught xt e raised to the power minus jk omega naught t into dt. So this is equation number 1. Now what is this integral? So where this integral t naught denotes the integration over the interval from 0 to t naught, or from minus t naught by 2 is less than or equal to capital T naught by 2. Now what is that? Setting k is equals to 0, so that ck is equals to 1 divided by t naught. It is xt e raised to the power minus jk omega naught t into dt. Now setting k is equals to 0, what we will get? C0 is equals to 1 divided by t naught, integration over that interval xt e raised to the power minus jk omega naught t into dt. So this is ck, c naught, this is c naught. And what is c naught? And what is c naught? So c naught is called that, c naught is called the average value. C naught is called the average value. So c naught is generally called the average value. So what we can find out, we can find out the conditions, various conditions. So the condition is if xt is real. The first condition, the condition is if xt is real, then what we will get here? We will get c minus k is equals to ck conjugate. Please check this. So if xt is real, then c minus k we will get ck conjugate. So we can prove this. So we can prove this. So ck is given as 1 divided by t naught integral over t naught xt e raised to the power minus jk omega naught t into dt. This is ck. Now if xt is real, then x minus t should be equals to, if xt is real, then if xt is real, then x conjugate t should be equals to xt. If xt is real, then this condition should satisfy. Now what we can find, that we can do here, we can do the conjugate. We can take conjugate on both sides. So what we will get? We will get ck conjugate is equals to 1 divided by t naught x conjugate t e raised to the power jk omega naught t into dt, because this conjugate will make it that minus sign to plus sign. Now what we can do here, so that this ck conjugate is equals to 1 divided by t naught, this x conjugate t, here we can write it as minus jk. We can write it as minus plus j, here we can use minus jk. Okay, so we can write in this manner. We can write j minus k, and we put minus here, omega naught t into dt. So it will make no harm, because this minus minus will become plus. So it is same as previous equation. But what is happening, that this c conjugate, ck conjugate will become equals to 1 divided by t naught. Since xt is real, so x conjugate t will be equals to xt. So it is equals to minus j minus k omega naught t into dt, and it is nothing but c minus k. So this relation is proved. So this relation is only valid when we have xt is real. So when we have xt is real, then c minus k will be equals to ck conjugate when xt is real. Let us see another property of this, and this is basically that representation in trigonometric Fourier series form. So the periodic signal can be represented, that we can represent it Fourier series in complex form as well as in trigonometric form for periodic signal. So this is trigonometric. So it is trigonometric Fourier series representation. Fourier series. So what is trigonometric Fourier series? Then here we can write xt is equals to a naught by 2 plus summation k is equals to 1 to infinity ak cos k omega naught t plus bk sine k omega naught t. And what is omega naught? So omega naught is, what is omega naught? Omega naught is 2 pi divided by t naught. Now what is ak and bk? So where ak and bk, where ak and bk are the Fourier series coefficients, are the Fourier series coefficients, it is given by that ak and bk is given by ak is equals to 2 divided by t naught xt cos k omega naught t into dt, and bk is equals to 2 divided by t naught xt sine k omega naught t into dt. So this is ak, this is ak, and this is bk. So this is ak and bk. Now c naught can be related with a naught by 2. C k is related with the ak and bk by this relation. So ak is equal to ck plus c minus k, and bk is equal to j times ck plus c of minus k. So this is the relation. Now we can prove this relation. We can prove this relation. So ck is equal to 1 divided by t naught, that interval is t naught xt e raised to the power minus jk omega naught t into dt. Now putting k is equal to 0, we get c naught is equal to 1 divided by t naught xt dt, and that is equal to a naught divided by 2. If we check the relation, if we check the definition of a naught, then it is equal to a naught divided by 2, then it is equal to a naught divided by 2. So c naught is equal to a naught divided by 2. So we have proved this relation. Now we can prove this relation also. We can prove this relation also. So this ck is written as 1 divided by t naught, that is integration of xt e raised to the power minus jk omega naught t into dt. Now we can see here that it can be written as xt cos k omega naught t minus j sine k omega naught t into dt. Now we can separate this. So we can separate this. We can write it as 1 divided by t naught xt cos k omega naught t dt minus 1 divided by t naught xt sine omega naught t into dt. So we have this relation. Now if we just take c minus k, so instead of k if we find out c minus k, so replacing in this equation, replacing k with minus k, we will get 1 divided by t naught xt cos, again this will same, but here we will get plus sign. So it is xt sine k omega naught t into dt, because sine is odd and cos is even. Now if we add these two equations, so addition of these two equations, what we will get here? We will get ck plus c of minus k is equals to 2 divided by t naught integration over t naught xt cos k omega naught t into dt, and that is equals to, if we just carefully see that, that is equals to ak, that is equals to ak. So what we are getting here, we are getting ak is equals to ck plus c of minus k. This is the relation we are getting. Again we can prove second relation also. So the ck, again I am writing ck, that is 1 divided by t naught xt e raised to the power minus jk omega naught t into dt. So what we are going to do, we are just finding the value of c minus k. So that is equals to 1 divided by t naught xt e raised to the power jk omega naught t into dt. Now if we subtract these two, then what we will get? We will get bk is equals to j times ck minus c of minus k. Please check this relation. Please check this relation. So this is our relation between bk and ck and c minus k. Now if we use these two relations, so we have ak, that is equals to ck plus c of minus k, and bk is equals to j times ck minus j times c of minus k. Now if we multiply this term by j, then what we will get? We will get ak is equals to ck plus c of minus k, and here we are getting j bk is equals to minus ck plus c of minus k. Now if we subtract these two quantities, so if we subtract these two quantities, so what we will get? So subtraction of these two quantities will result as that is relation between ck and ak and bk. So the subtraction will get what we will get? We will get ck is equals to, so just subtracting this and with this equation, we will get ak minus j times bk divided by 2. So this ck is ak minus j times bk divided by 2. Similarly, just mathematical manipulation will lead to that c minus k is equals to 1 by 2 ak plus j times bk. So all these are relations that we need to remember. So let us summarize this. So ck is equals to ak minus j bk divided by 2, and c of minus k is equals to ak plus j times bk divided by 2. So this is ck and c minus k. Now if we consider that xt is real, then ak, what is ak? Ak is 2 times real part of ck, and what is bk? Bk is minus 2 times imaginary part of ck. So this ak is 2 times real part of ck, and bk is minus 2 times imaginary part of ck. So these are two values that we are getting. For even and odd signal, let us discuss some property. So if for even signal, so if gt, if xt or gt, whatever we can take, so better to take xt. So if xt is even signal, then x of minus t is equals to xt. So this is the definition of even signal. Now if we just carefully see that expression of ct, then ct is equals to a naught divided by 2 plus summation k is equals to 1 to infinity ak cos k omega naught t plus bk sine k omega naught t. So this is the expression for this xt. Now if x of minus t is xt, then what we will get here, it is what we can find out that the coefficients related to means that bk will be equals to 0. The first thing is that bk is equals to 0. So what we will get here, bk is equals to 0, because bk, what is bk? If we go to the definition of bk, then bk is if we write the expression of bk, so it is 2 divided by t naught integral over t naught xt sine k omega naught t into dt. Now if xt is real, so if xt is real, if this is real, then this is odd signal. That sine signal is always odd, so sine is odd, xt is real. Then what we will get, the real multiplied by odd will always results odd signal. So real multiplied by odd signal will results odd signal. Now if we integrate any odd signal, so this is sine signal, let this sine signal is our odd signal. Now if we integrate sine across the period from 0 to 2 pi, then plus area and minus area will cancel out. So bk will be equals to 0. bk will be equals to 0. If xt is an even signal, then bk is equals to 0. So what we will get? We will get only ak. We will get only ak and a naught by 2. That bk is equals to 0. So xt is written as a naught by 2 plus summation k is equals to 1 to infinity ak cos k omega naught t. So this is our xt. This is our xt. Now if xt is odd, now let us say take the second case. If xt is odd, if xt is odd signal, then what we will get, if we just see the definition of ak, then what is the definition of ak? It is simply 2 divided by t naught xt cos k omega naught t into dt. If xt is odd signal, then this is odd and this is even. So again odd into even will result odd. Now if this is odd, then again we integrate across the interval, then ak will is equals to 0 and also a naught will also equals to 0. If xt is odd signal, then a naught also equals to 0. So ak is equals to 0. So what we will get finally, we will get only bk. So it is equals to if xt is odd signal, then we are getting only bk, and that is equals to summation k is equals to 1 to infinity bk sine k omega naught t. And what is omega naught? So omega naught is equals to 2 pi divided by t naught. Omega naught is equals to 2 pi divided by t naught. Okay, let us discuss another very important series, that is harmonic form Fourier series. This series is called the harmonic form. This series is called the harmonic form Fourier series. This series is called the harmonic form Fourier series. So according to this series, it is very important series. So another form of the Fourier series, basically representation, is real periodic Fourier series representation of real periodic signal of fundamental period T naught is basically we can represent it as xt is equals to C naught plus summation k is equals to 1 to infinity ck multiplied by cos omega naught kt minus theta k. So this is basically that harmonic representation of the Fourier series. This is called the harmonic representation of Fourier series. So xt is equals to C naught plus summation k is equals to 1 to infinity ck cos omega naught kt minus theta k. And what is omega naught? So omega naught is equals to 2 pi divided by t naught. So this basically that another form of the Fourier series representation of a real periodic signal xt with fundamental period t naught is ext is equals to C naught plus summation k is equals to 1 to infinity ck cos omega naught kt minus theta k. So what is omega naught? It is 2 pi divided by t naught. So this is called the harmonic Fourier series. So the series is called the harmonic Fourier series of xt. Now what is that omega? So that the form of basically what is the value of C naught? So basically not omega, C naught. So what is C naught? So C naught is also called the DC component, or it is called the average value, or also it is called the average value. So C naught is basically DC component because there is no frequency component involved. Please understand that in C naught there is no frequency component involved. That's why it is called the DC component, because in DC the frequency is 0. So and this basically, and the term this term ck cos k omega naught t minus theta k, this term is basically called the kth harmonic component of xt. This term is called the kth harmonic component of xt. So this term is called the kth harmonic component of ext. So C naught is basically the DC component, and ck cos k omega naught t minus theta k is basically the kth harmonic component. So this is the harmonic representation of the Fourier series. So the first harmonic component is, so if we put the k is equals to 1, then C1 cos omega naught t minus theta 1, this is called the first harmonic component. This is called the first harmonic component. So this first harmonic component is commonly called the fundamental component. Okay, so this first harmonic component, so this first harmonic component is also called the first harmonic component is also called the fundamental component, is also called the fundamental component, is also called the fundamental component because it has some fundamental period as xt, because it has some fundamental period, because it has some fundamental period because it has some fundamental period as ext, it has some fundamental period as xt. So the coefficient ck and the angle theta k are called the harmonic amplitude and phase angle. So this component ck and the coefficient ck and theta k is basically and the angle theta k is called the are called the harmonic amplitude. So this is basically that harmonic amplitude and angle. So this theta k is called the harmonic amplitude. This is called the harmonic amplitude, and this theta k is called the angle, harmonic angle. This theta k is called the harmonic angle, and they are related with basically that they are related with ak and bk. So c naught is equals to a naught divided by 2. And what is ck? So ck is equals to under root of ak square plus bk square, and theta k is equals to tan inverse bk divided by ak. So theta k is equals to tan inverse bk divided by ak. So this is the relation. So these are very important relation. We need to understand that c naught is equals to a naught divided by 2, ck is equals to under root ak square plus bk square, and theta k is equals to tan inverse bk divided by ak. Let us discuss the convergence of Fourier series. So let us discuss the convergence of Fourier series. So it is known that a periodic signal xt, a periodic signal xt has a Fourier series representation, has a Fourier series representation if it satisfies the following Dirichlet conditions. If it satisfies the following Dirichlet conditions. So what are the conditions? So first condition is if xt is absolutely integrable, if xt is absolutely integrable over period, over any period, that is modulus of xt integrable over any period t naught or interval t naught is less than infinity, that t naught is any time period, particular time period. So if this is the condition, then this is called the first condition of Dirichlet. So second condition, this is not only the first condition, there are some other conditions also. if xt is a finite, also xt has a finite number of maxima and minima within a finite interval of t. So xt has a finite number of maxima and minima within any finite interval of t, and next thing is xt has a finite number of discontinuities. xt has a finite number of discontinuities. xt has a finite number of discontinuities within any finite interval of t. And each of the discontinuities is finite, and each of the discontinuities is finite. So next thing is what is the amplitude and phase spectra of a periodic signal. So next is the amplitude and phase spectra of a periodic signal. The amplitude and phase spectra of a periodic signal. So let us discuss this. What is that ck? So ck can be written as modulus of ck e raised to the power j phi k. So what is that plot? So a plot of modulus of ck. So a plot of modulus of ck versus the angular frequency omega is called the amplitude spectrum. Is called the amplitude spectrum of the periodic signal xt, of the periodic signal ext, and a plot of, so the plot of c modulus of ck versus omega, this is called the amplitude spectrum. Now second thing is a plot of theta k versus omega is called the theta k versus omega is called the phase spectrum of xt, is called the phase spectrum of xt. So since the index k Since the index k assumes only integers, so the amplitude and phase spectra are not continuous curves. So basically what we have assumed that the index k is only integers, so the amplitude and phase spectra, the amplitude and phase spectra are not continuous curves, but appears only at the discrete frequency k omega naught. But it appears only at the discrete frequency, k omega naught. It appears only at the discrete frequency k omega naught. So they are therefore referred to as discrete frequency spectra or line spectra. So they are therefore referred to as discrete frequency spectra or line spectra So for real periodic signal, so as we know that for real periodic signal that C minus K is equals to CK conjugate. So taking the modulus both sides, so CK conjugate is equals to modulus of C minus K, and this phi minus K is equals to minus of phi K. This phi minus K is basically the minus of phi K. So what we can say from these two relations, we can derive a very important result, that hence the amplitude spectra is an even function of omega for real periodic signal. For real periodic signal, the amplitude spectrum is an even function of omega, and the phase spectrum is an odd function of omega, for a real periodic signal, Now let us discuss another very important topic, that is power content of periodic signals. That is power content of periodic signal. So let us discuss this. So the power content is basically, we can calculate the power across the interval. So P is equals to 1 divided by T naught modulus of xt whole square dt. So this is the way to find out the power of periodic signal, and also we can use the Parseval's theorem. So also we can find out power by second method. So this is the first method, and it is equals to, if we know the coefficient ck, then also we can find out the power by using this relation. So it is summation, or k is equals to minus infinity to plus infinity modulus of ck square. Basically, if we know the ck coefficient, then only amplitude of that squared amplitude of that coefficient will and the sum of all these coefficient will gives us the power. So this condition, theorem is called the, so that this equation, the equation given is known as Parseval's theorem, is known as Parseval's identity, or Parseval's theorem for Fourier series. Next topic is Fourier transform. So let us discuss that how that we have derived the Fourier's means we have derived the Fourier transform from the Fourier series. So the Fourier series. So from Fourier series to Fourier transform. From Fourier series to Fourier transform. So let xt be a non-periodic signal, Let xt be a non-periodic signal of finite duration, So xt be a non-periodic signal of finite duration. So that is xt is equals to 0 for modulus of t greater than capital T1. So let us plot xt first. So what is xt? So xt is from minus T1 to plus T1. This value has some value, and from T1 to infinity, and from minus T1 to minus infinity, so from minus infinity to minus T1, and from T1 to infinity it is 0. So this is our xt. Let xt naught t be a periodic signal, and it is formed by repeating xt, with fundamental period t naught, as shown below. So xt naught t, so it is formed by this relation. So it is 0, it is T1, it is minus T1, then here we have T naught, then 2T naught, then minus T naught, minus 2T naught, So this is the periodic signal. This is periodic signal. Now what we can find out, so if we, okay, so if we let t naught tends to infinity, so if we let that t naught tends to infinity, that is the time period tends to infinity, so what we can find out, that we have this relation. If the time period t naught tends to infinity, then it is equals to xt. Please understand that if time period t naught tends to infinity, that is equals to xt only. That is equals to xt only. So the complex exponential Fourier series of xt naught t. So the complex exponential Fourier series of xt naught t is given by xt naught t is equals to summation k is equals to minus infinity to k is equals to plus infinity ck e raised to the power jk omega naught t. And what is omega naught? So omega naught is 2 pi divided by t naught. So what is omega naught? It is 2 pi divided by t naught. Let this is equation number 2. And what is ck? So where ck is that Fourier complex Fourier series coefficient, and this is equals to minus t naught by 2 to plus t naught by 2 xt naught t e raised to the power minus jk omega naught t into dt. That this is equation number 3. So since x t naught t is equals to xt, since x t naught t is equals to xt for modulus of t less than t naught by 2, because x naught t is equals to xt for modulus of t less than t naught by 2, and also since xt is equals to 0 as it outside the interval, so ck can also be rewritten as, so ck can be rewritten as ck is equals to 1 divided by t naught from minus t naught by 2 to plus t naught by 2 xt e raised to the power minus jk omega naught t dt. So this is equation number 4. Now it is equals to 1 divided by t naught minus t naught by 2 to plus t naught by 2 xt e raised to the power minus jk omega naught t into dt. So just we have simply written that. Now what we can find out, so let us define xk. Let us define x omega. There is that capital omega as, so x omega, let us define this as minus infinity to plus infinity ext e raised to the power minus j omega t into dt. Let us define this. So we have defined this as omega, and let this is equation number 5. Now we can substitute. So we can substitute 5 in 4. So substituting 5 into 4 we get, so this is fifth equation and this is fifth equation, and this one is fourth equation. So substituting fifth equation into fourth equation, what we will get? We will get Ck is equals to 1 divided by T naught x k omega naught. So this is equation number 6. This is equation number 6. Now substituting 6 into 2, we obtain, substituting 6 into 2, we obtain x t naught t is equals to summation k is equals to minus infinity to k is equals to plus infinity 1 divided by T naught x k omega naught e raised to the power j k omega naught t. And what is x t naught t basically? So we have x t naught t is equals to 1 divided by 2 pi summation k is equals to minus infinity to k is equals to plus infinity x k omega naught e raised to the power j k omega naught t, and this is equation number 7. Now as t naught tends to infinity, omega naught is equals to 2 pi divided by t naught becomes, it will become infinitesimally small, infinitesimal small. It is very small quantity, and what is happening that omega naught tends to 0. When t naught tends to infinity, omega naught tends to 0. Thus let omega naught is equal to delta omega, because it is very small, so we can replace omega naught is equal to delta omega, and thus equation 7 becomes x t naught t, for t naught tends to infinity, so it will become 1 divided by 2 pi summation k is equals to minus infinity to k is equals to plus infinity x k delta omega e raised to the power j k delta omega t multiplied by delta omega. So this is equation number 8. This is equation number 8. Now so we can write that therefore xt is written as limit t naught tends to infinity x t naught t, and it is equals to limit delta omega tends to 0, 1 divided by 2 pi summation k is equals to minus infinity to k is equals to plus infinity x k delta omega e raised to the power j k delta omega t multiplied by delta omega. So this is equation number 9. So the sum, basically the sum m, basically the sum on the right hand side, that sum on the right hand side of this equation, so the sum on right hand side of equation 9 can be achieved as the area under the function x omega e raised to the power j omega t. So we can draw the graph. So let us see the graph here. So we have x omega e raised to the power j omega t, here we have, and here we have omega with respect to omega. Then this is the graph. This is the graph. Now we can see that if we plot the graph here, then we can see that this is the area. So this is the area x k delta omega and e raised to the power j k delta omega into t multiplied by delta omega, and this is k delta omega, and that width is basically that delta omega. The width is basically the delta omega. And if we see that the amplitude of this point is x k delta omega e raised to the power j k delta omega into t. So what we obtain, so therefore we obtain xt is equals to 1 divided by 2 pi minus infinity to plus infinity x omega e raised to the power plus j omega t into d omega. So this is the relation. So which is the Fourier's representation of non-periodic signal xt. So this is the Fourier representation of, so this is the Fourier representation of non-periodic signal xt. So this is the Fourier representation. This formula is the Fourier representation of the non-periodic signal xt. So let us discuss the Fourier transform pair. So the Fourier transform pair. So what is the Fourier transform pair? So that x omega is equals to Fourier transform of xt, and that is equals to minus infinity to plus infinity xt e raised to the power minus j omega t into dt. And if we find out the inverse Fourier transform, that is Fourier inverse of s omega, then it is equals to 1 divided by 2 pi minus infinity to plus infinity x omega e raised to the power j omega t into d omega. Please understand, here we have d omega. So this is the Fourier transform, and this is the inverse Fourier transform. So this formula is called the Fourier So this is Fourier transform pair. So generally we are just representing in like this. Generally we are representing in this manner. So this xt is the discrete continuous time signal, and x omega is the Fourier transform of this ext. X omega is the Fourier transform of this ext.